In part 1, we created a blueprint in our first-person character to handle jetpack thrust and fuel consumption. Today, we'll kick it off with velocity damage. In future parts, we'll cover some sound effects and of course our little jetpack game interface to show the health and fuel progress bars, as well as create an on-death event that ends our game. Let's start by tracking our damage and health. Hopefully you can guess by now from the last video, but we could probably start with some new variables. Let's add health as a float and set the default to 100. Let's also add impact multiplier and keep that afloat as well. Again, how do I know all these variables that I should add? Well, I don't. I just think of a couple that could be useful, which helps me scope out what we can start to work on for this graph. If we think of more later, that's totally fine. We'll handle that when we get there. For now, let's add a new graph, which we can call velocity damage. New event graphs are just a nice way to stay organized. Notice I'm calling it velocity damage and not just fall damage. That's simply because in addition to hitting the floor, I also want to account for maybe flying into things too fast or hitting our head on something above us. I think that'll make for a more interesting three-dimensional game. Naturally, most event graphs start with an event. If we were doing fall damage only, there's a nice event called event on landed. Since we want to hit stuff in all directions, let's instead use event hit. Now, this should trigger when we hit something, like landing on the ground. To test, let's just do a print string. Let's type in ouch. Compile, let's play test. If we jump up and hit the ground, ouch. Let's duplicate this level block, place it above our head, and let's test again. When we fly up, ouch, 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 ouch. Same thing when we hit a wall, lots of ouch. Good, we're hitting stuff. We'll refine this, but at least we know it works. One problem though is we don't want to say ouch every time we stub our toe. We want to reserve actual damage for when we really take a hit. How do we do that? Well, for starters, we can get our velocity. That's kind of how fast we're going when we hit something. We only want to be hurt if we're moving fast enough. So let's try get velocity. This seems good, right? Target is self, and let's just print that velocity. When we test, and again, this is why playtesting is so important, we jump up, we land, but something's off. Z velocity is still 0. Realistically, or what I'm going for, we should be hitting the floor and getting some action on that Z-axis. So what's going on? Well, as a hint, in our first-person character, one component here is responsible for collisions, which is basically just colliding or hitting other objects. If you guessed it's the collision cylinder, good job. That's this cylinder here. Back in our velocity damage graph, let's just drag and drop to get that capsule component, the collision cylinder. Delete what we had. Now, off of this, let's drag get velocity. And we want to get this component's velocity. We're being a little bit more specific. A component is just all this stuff that's added into our first-person character blueprint. If we print this one, now you can see our component is actually colliding and we're getting some reliable velocity data even on that Z-axis. Now let's play with something called vector length. So from our velocity, let's do vector length. The vector length used here measures how fast something is moving. When used with get velocity, it gives the speed we were going when we hit, by calculating the magnitude of the velocity vector, regardless of direction. If that doesn't make sense, just look at what it does. So if we print this, instead of 3 values, x, y, and z, we just get one number. How hard did we hit whatever we hit? That's all we really need. Now let's multiply this by our impact multiplier. I can't remember if we set that initially, but let's make the default like 0.05. Then get with control drag and multiply. Now those numbers are looking a bit smaller. Again, the point of a variable here is to make changing it easier later on down the road. Let's say our player buys more armor plating and now fall damage doesn't hurt so bad. Impact multiplier is our ticket for that. As I test this though, honestly, anything under like 60 feels like not a big deal. Just walk it off. I certainly don't want to lose 1 health for a 1 velocity fall. So let's do some branch logic. If this velocity is greater than 60, then we print. If not, nothing. Now, when we test, we don't start seeing damage until it's pretty significant. But I'd rather not take a minimum of like 60 damage. That's over half our health. I'd rather 60 be the new 1 and 100 to still be 100. For that, we need to do something called mapping our range. And we can clamp that as well. So let's add the map range clamp to super useful node. The in range A is now 60. That's kind of like our before minimum. In range B is 100. That's our before maximum. So what was 60 to 100 before is now 0 to 100. Basically, we've remapped that range, the specific range, to fill the new 0 to 100. It's 0 to 100 because that's our health range. 0 is no health, 100 is maximum. If you're confused, just test it out. Play with the numbers until you tune this to whatever feels right. The most damage we'll ever take is 100, which is basically instant death. Meanwhile, walking into walls, doing small jumps really shouldn't hurt. There's one small bug that you may or may not encounter, which again is why playtesting is so important. But I noticed this after watching my kids play. They got damage multiple times in quick succession when they landed on a sloped surface, one that's too steep you can't walk up. We see that on a ramp here. Instead of taking a single velocity damage, we take the same one like 8 times. Obviously, that's not good. So to fix it, I just added a do once node. In this case, we'll place it before the print string, which represents damage for now. Then after print string, let's add a retriggerable delay. Why? Well, we don't want to do damage just once forever. We'd like to do damage just once, then maybe trigger a delay at like 1 second. And after that 1 second is complete, then we can send completed into the do once reset. So now we do damage only 1 time every second, which fixes this little bug where we slide down a ramp at high velocity and take like 8 to 10 damages at once. You can go ahead and test it. Of course, change the retriggerable delay duration to whatever feels good. 1 second worked for me. Of course, up until now, we're just printing strings. We're not actually hurting the player. So let's do that. Delete the print string. I'm sure it'll be back, and add the node apply damage. Now we could do lots of different stuff here. Apply damage is a good one to know simply because it's part of Unreal's pre-built damage system. We won't take full advantage of it right here, but now you know it exists. To calculate the base damage, let's just drop in the value we already have. Make sure into the damage actor we simply place self, which is basically our whole first-person blueprint. I'm just going to double-click this return noodle here to get organized. So after we apply damage, I'd like to change the health. So let's get the health variable, control drag. This should be 100 by default, and let's simply subtract the damage return value. We have get health, we subtracted, now we need to set health. So alt click and drag. Now of course, let's print string here so we can see what we've got. Maximum damage is 100, so a big fall basically sets our health to 0, which is perfect. But notice if we fall again and we take damage after death, which I guess doesn't really matter, but it's possible to go negative here. We could fix that again simply with a clamp float, just go from 0 to a maximum of 100. And that's before the new set value. So now we never set a new health value above 100 or below 0. Now we're good. We can delete our print string. Fun tip here, just hold shift and delete to maintain the node connections. Cool, so the velocity damage system is essentially done. We got it working and even crushed some bugs that we discovered. Thanks to the first video, we have thrust, we have fuel consumption and regeneration. Now we have a nice health and velocity damage system. From here, we like some sounds, maybe some grunts and groans when we get hurt, as well as the jetpack thruster sound. And of course, we still need an interface for some fuel and health bars. All of that's coming in future parts to this training, so subscribe and I'll be back to finish this off before you know it. If you don't want to wait, all parts are available right now as early access for my Patreon subscribers of at least the lowest tier, $3 or more. That's patreon.com/RileyB3D. It's by far the best way to support this channel. Once again, let's zoom out and admire our work so far. Hopefully, I'll see you in part 3 and beyond, either right now if you support on Patreon or over the next few weeks. Again, we'll wrap it up with sound effects and a nice interface.